right, let's see. Okay, with this one you just got to go for it with the definition. There's no, it's not a p-value. A p-value only works when you have something here, 1 or 2 to infinity, and 1 over x to the p. If you have a number here, like say 3, that'll still work. You could pop the 3 out and then make it 3, but we don't have that here, right? We have 2 over x to a power minus x. So it's not just x to a power, it's not a p integral. And so that's not going to work. All right, so we'll just have to compute the integral. Now, we can do this in a couple different ways. You can keep the limit with you the whole time. Often that's confusing for students, so let's just do it the way that we do it in WebAssign. All right, so we'll compute from 2 to r, 2 over x squared minus x dx. Now using partial fraction decomposition, we can write this as negative 2 over x plus 2 over x minus 1 dx. All right, so now taking the antiderivative, we've got negative 2 ln x plus 2 ln x minus 1. We're going to evaluate that from 2 to r. Okay, so here we've got negative 2 ln r plus 2 ln r minus 1 minus negative 2 ln 2 plus 2 ln 2 minus 1 is 1. And now remember that ln 1 is 0, so this is just 0 here. So all this work, we find that this is equal to negative 2 ln r plus 2 ln r minus 1, ln of r minus 1 plus 2 ln 2. Right, so let's see, distributing that negative through, right, that would be a plus there. This is just 0, so we don't need to worry about that. Okay. All right, now I think dealing with this is going to take a little bit of effort. Let's see. All right, so using some rules of logarithms. Let's see, now the issue here is that like when you plug in, when you take the limit, as r approaches infinity, you get infinity plus 2 ln 2. Now, if you just got infinity by itself, that would be something we can interpret. That's a determinate form, but an indeterminate form is infinity plus infinity. What does that mean? So here we have an issue. If we just plug in infinity and get infinity plus a constant, it's like, what does that mean? We don't really know. So we need to do some algebra to figure out, okay, what is really going on here. So what I would do is, so we can move this up into there, right? We can move this up to there, exponent. That's a rule of logarithms, right? So you have ln r to the negative 2 plus ln r minus 1 squared plus 2 ln 2. Now this right here, r to the negative 2, that's 1 over r squared. So I'll write it like that, 1 over r squared. And now using a rule of logarithms, remember that, let's see, of ln of a times b is equal to ln a plus ln b. So I'm going to go that direction with that. This being my a there, that being my b there. This is equal to ln r minus 1 squared over r squared plus 2 ln 2. Okay, oops. This square should be up there like that. All right, now let's see. You could use L'Hopital's rule and a trick where, because the natural log is continuous, you can pop the limit inside, or you could do more algebra. I think that's the way to go about it. So let's see, r minus 1 squared over r squared so r minus 1 squared, let's see, that's r squared minus 2r plus 1. Let's see, r squared plus 1, and then you have negative r, and negative r would make negative 2r. Right, so then now you could go do this r squared over r squared minus 2r over r squared plus 1 over r squared. And this becomes 1, like that. Okay, so basically what I'm saying here is that you can divide this into each of these terms to get 1 minus 2 over r plus 1 over r squared. And so here we have ln of that thing, 1 minus 2 over r plus 1 over r squared. Plus 2 ln 2. All right, so I think now we're ready to take the limit. So now, remember that from 2 to infinity, 2 over x squared minus x dx, this is the limit as r approaches infinity of the integral from 2 to r. 2 over x squared minus x dx. Well, which is equal to, right, because this is equal to this. This is equal to the limit as r approaches infinity of ln 1 minus 2 over r plus 1 over r squared plus 2 ln 2. Now think about what happens as r approaches infinity. As r gets large, this goes to 0, and this goes to 0. This stays constant. And then we have ln of 1. ln of 1, so this whole thing becomes 0. And we're left with 2 ln 2. That's a number, so therefore this thing converges.